Hey everyone, so our next section is about volume. So I just wanted to first talk about what volume is. Most of you probably already know this, but that's okay. So it's basically like the amount of space that a figure encloses. So like how much space is inside of a 3D figure. Um, it's measured in cubic units, which is really important. So, like area and surface area are square units. Volume is cubic because it's three dimensional and we want to know like what's filling it up. So, that's what volume is. I gave you this formula sheet on Classroom. And so I just wanted to talk a little bit about some of the shapes. I wish I had my solids from school, but I don't. But basically, I'll just go over each one. Rectangular prism. I'm sure you guys already know what that is. It's basically like a box. Prisms. Now, prisms can be a little bit tricky. There are different types of prisms. You could have a triangular prism like that. This is a trapezoidal prism. You could have a hexagonal prism, a pentagonal prism. There's all different types of prisms. Prisms are made up of a base. So see how the shaded part is the base. The base determines what type of prism it is. So a triangular prism has a base that's a triangle. A trapezoidal prism has a base that's a trapezoid. A hexagonal prism has a base that's a hexagon, and so on. The rest of the faces, so the top and the bottom, are the bases. Those are like the distinct shape that makes it that prism. Then the rest of the sides are made of rectangles. So when you are finding the volume rather of a prism, this is the basic formula. Now, this capital B stands for area of the base. So every prism is going to be different because it's going to have a different base. So, like for a trapezoidal prism like this, you would do the area of the trapezoid times the height of the prism. For a triangular prism, you would do the area of the triangle times the height of the prism. So it's always the area of the base times the height of the prism. A right circular cylinder is also area of the base times the height. Which area of the base is a circle. So that's going to be pi r squared and then times the height of the prism. I'm not going to talk about SA. SA is surface area. That's going to be next time. Square pyramid. So it doesn't just have to be a square pyramid. It could be a rectangle too. But for that one, you're doing area of the base times the height and then times 1/3 or divided by 3. So I usually will do this. So area of the base times the height over 3. It's a little bit easier than putting in 1/3 in your calculator. But the base can be a square or it could be a rectangle. It depends on the situation. Then we have a cone, a right circular cone, and that's area of the base times the height divided by 3 also. So that's really like pi r squared times the height over 3, which is the same thing as saying 1/3 capital B H, 1/3 times the area of the base times the height. So, oh, one more. Just kidding. Sphere. So a sphere is 4/3 times pi times r cubed. So like if you wanted another way to write this, you could write 4 pi r to the third over 3. Same thing. Okay, so those are the formulas. I'm just going to go through a couple examples, like maybe one of each one. I don't even know if I need to go that far because volume is pretty easy. So first I already did one of them before. This is a rectangular prism, length times width times height, very basic. You guys know how to do that. So something like, say, number 4, that's a triangular prism. And so I can tell because it's made of 2 triangles and then 3 rectangles. So for this, it's going to be the area of the base times the height. The area, so the height, okay, let's talk about this. The height of the prism, this is not the height of the prism. The height of the prism is the height of like the rectangles. So picture like if this triangular prism was laying flat on the triangle side and then like the rectangles would be coming up. So this is the height of the prism. And then for the area of the base, it's a triangle. So we need 1/2 times base times height of the triangle. So this is the height of the triangle. This is the base of the triangle. We actually don't know that, but we can find it. So if this is 34, this is 34, you can do Pythagorean theorem to figure out that base. So I'll just do that real quick. So it would be like this squared plus 16 squared equals 34 squared, and then you would solve. So 34 squared minus 16 squared is going to be 30. So this is 30. So this is the base of the triangle. This is the height of the triangle. So this part of it, this remember means area of base, is 1/2 times 30 times 16. So then you would just multiply all of that, and then that would be your volume. So 0.5 times 30 times 16 times 22. So it's going to be 5,280, and then it's cubic inches. Okay, next I'm going to do this cylinder. So a cylinder's area of the base times the height. So area of the base is going to be pi r squared. So pi times 15 squared times the height of the cylinder, and that's it. Pretty simple. So 225 times pi times 23. This one's going to be 1,600. Oh, just kidding. This one's going to be 16,257.74 millimeters cubed. Okay, so there's a cylinder. Next, I'll do a pyramid. So this one is a rectangle pyramid. So see how it's a rectangle on the bottom? So it's going to be area of the base times the height divided by 3. That's for a pyramid. So area of the base, it's a rectangle. So that's going to be 25 times 12.5 times the height of the pyramid, which is here. Remember that the height is perpendicular to the base. So it's the same with the 3D shape. The height of the shape is this. There is something called a slant height, which is this, but that's used in surface area. So we'll talk about that next time. So I have area of the base times the height divided by 3. So this would be 2,395.83 centimeters cubed. So there is a pyramid. I'll do a cone next. Let's do this cone. So we have remember formula for the cone is also area of the base times the height divided by 3. So that's going to be pi r squared times the height over 3. So for this one, it's going to be pi. The radius is 9. So 9 squared times the height of the pyramid we need. So we need to find this. I just realized they gave us the slant height. So again, you're going to have to do Pythagorean theorem. It's this squared plus this squared equals 19 squared. So really just 19 squared and then minus 81 and then the square root of that, which is 16.73. And then that's going to be divided by 3. So pi times 81 times 16.73 and then divided by 3. So this one's going to be 1,419.09, and that's cubic feet. Okay, so that's a cone. And then I'll do a sphere. And then I think I hit all of them. So a sphere is pretty easy. Remember the formula is 4 pi r to the third over 3. So that's going to be 4 pi 6.5 to the third over 3. So I'm going to do the 6.5 to the third first, which is 274.625. And then I'll multiply that by 4 pi and then divide by 3. So this one's going to be 1150.35 cubic centimeters. Oh, this one, I just realized these directions ask for surface area, but that's okay. Same thing. Well, no, it's not the same thing. Volume and surface area are very different, but I can use this picture to find the volume. So just ignore those directions. Let's see, what else? Sometimes you might be asked to find the volume of a hemisphere. So you would just do the full sphere and divide by 2. It's just half of the sphere. So that's it for the basic ones. we probably will have like a big quiz slash test quest, whatever you want to call it, right at the end, our last class probably. So on it for this unit, we usually have something called composite figures. You guys did composite figures with area, like 2D, where it was just like a few different shapes put together. To find the surface area or volume of a composite figure like this, you have to visualize like what the 3D shapes are. So like this one, for example, this is a cone and this is a cylinder. So you would find the volume of the cone, the volume of the cylinder, add them together. So it is pretty easy. I just figured I'm attaching this to Classroom, and I'll write in the directions that this paper, there's 3 of them. I'm going to make this one optional. Like if you want to do it, you can. There probably will be something like this on the eventual like quiz or test that we have. So if you just want to try one or even just watch this video, it's pretty easy. So if you have a cone and a cylinder, you need to find the volume of each one. So the volume of the cone is base area of the base times the height divided by 3. The cylinder is just area of the base times the height. So let's see if we have everything. For the cylinder we have the radius and we have the height. So the cylinder we can do, area of the base is pi times r squared times the height of the cylinder, which is 12. So this is going to represent the cylinder. For the cone, we do have that the radius is 5, but we don't have the height. We have the slant height. That's this right here. That's used for surface area, which again, we haven't learned about yet. But the regular height is what we need for volume. So you have to do Pythagorean theorem. 13 squared minus 5 squared is going to be 144. This is going to be 12. So that means that the height of the cone is also 12. So for this part, it would be area of the base, so pi r squared, pi times 5 squared times the height of the cone, which is 12, divided by 3. So you're going to calculate each of these, and then we just add it together. So let's see, 25 times pi times 12 divided by 3 is 314.16, and then 25 pi times 12 is 942.48, and then just add those together. So 314.16 plus 942.48, and it's 1256.64. And this would be cubic centimeters. So that would be the volume of the entire shape. Okay, so that's all the examples I'm going to do. If you guys want to try these 2, I'll put the answers on Classroom so you can see if you're doing it correctly. And then the rest of the practice is going to be on IXL. All right, that's it. Let me know if you have any questions, and have a great day.